Let's practice checking solutions to inequalities. We've done so a few times in the previous videos, and I just want to do a separate video on checking solutions to inequalities, just so we get really familiar with it. And it's very, very important to check solutions, just as like it was important to check solutions to equations. So let's say that we want to check that the solution interval contains x equals 5. X equals 5 is in the solution interval for the following inequality. 11x is greater than 50. So we want to check that in the given solution interval for this inequality that x equals 5 is contained in it. So what we do is everywhere we see x in our inequality, we plug in 5 for x. So let's go ahead and do that. Works the same way as checking the solutions for equations like we did in the previous section. So we have 11 times 5 is greater than 50. 11 times 5 is 55. We still have our greater than or equal to 50. And that actually checks out, which means x equals 5 is a valid solution for this inequality. Now note that x equals 5 is not the only solution, but it's a solution contained in the solution set for this inequality. Okay, so this isn't actually the only solution. I believe we talked about that earlier. The solution for an inequality is actually an interval, whereas the solution to an equation is usually just a number. All right, so let's look at a few more. Let's say y equals -1 is supposedly in the solution set for the following inequality. 2 plus y divided by y is less than or equal to -1. So we want to check that this is a value contained in the solution set for this inequality. So we go ahead and plug in, wherever we see y in our inequality, we plug in -1. So let's go ahead and do that. We have 2 plus y, which is -1, divided by y, which is -1. We always want to put whatever we're substituting into our equation or our inequality, we want to put in parentheses just to clarify things. We have our less than or equal to sign and -1 on the other side. So let's go ahead and solve this out. So we have 1 divided by -1 is less than or equal to a -1, and which is just gives us -1 divided by, or excuse me, -1 is less than or equal to -1. All right. Now notice we didn't have to flip the sign here. Even though we're getting division by 1, or division by a negative sign, this isn't the same as dividing both sides by a negative number. Here we actually have the number -1, which can be written as 1 divided by -1. So don't get this confused with dividing both sides of the inequality by a negative number. We don't flip the inequality sign here. Even though it wouldn't matter here, because even if it was greater than or equal to, -1 is still equal to -1, so we wouldn't see the difference here, but this is a -1, so it doesn't matter that we're writing it as 1 over -1. So I just don't want you to get confused over that. All right, so this checks out. -1 is definitely either less than or equal to -1, so this is a valid value for our solution set. So -1 is contained in the solution set for this inequality. All right, so let's look at a few more. Let's say we're given a equals 2, and we want to know that the solution interval for the following equation contains 2. So we have 2x plus 4 is greater than 6. So let's go ahead and, well, this should be a. Sorry about that. We have 2a plus 4 is greater than 6. So everywhere we see a in our inequality, we're going to plug in 2. So let's go ahead and do that. We have 2 times a, which is 2, plus 4 is greater than 6. 2 times 2 is 4, plus 4 is greater than 6. And we have 4 plus 4 is 8, which is greater than 6. That checks out, which means a equals 2 is a solution contained in our interval that satisfies the inequality. Okay, so it's not the only value in the solution set, but it's one value. So that's all we're checking. We don't want to check every solution in the interval for this inequality. We just want to check a particular given value. So let's go ahead and do another one. We have b equals minus 2, and we want to know if this value is contained in the solution interval for the following inequality. We have b over 2 plus 4 is less than b plus 12. Okay, now here we see our variable on both sides of the inequality sign, but this doesn't make a difference. Everywhere we see b, we're going to plug in a minus 2. So we have minus 2 divided by 2 plus 4 is less than b, which is minus 2, plus 12. Let's go ahead and do the math here. We have a minus 1 plus 4 is less than minus 2 plus 12 is just a positive 10. Minus 1 plus 4 is 3. 3 is less than 10 is a true statement, which means b equals negative 2. Negative 2 is contained in our solution interval for this equation. This inequality. So that checks out. Let's go ahead and look at another one. Let's look at, we're given a equals 2, and we want to know if this is a value that's contained in the solution interval for the inequality 3 times a plus 2 is greater than or equal to 6a. Okay, so let's go ahead and plug in 2 everywhere we see a in our inequality. So we have 3 times a, which is 2, plus 2 is greater than or equal to 6 times a, which is 2. This is a 6. All right, let's go ahead and add this inside parentheses first. So 3 times 2 plus 2 is 4, greater than or equal to 6 times 2, and multiply these two, we get 12 is greater than or equal to 12. 12 is equal to 12, so that checks out, which indeed 2 is included in the solution set for this inequality. All right, let's look at a few more. This is good practice. Checking our solutions to inequalities. We want to check that the value minus 1, b equals minus 1, is contained in the solution interval for the inequality 5b plus 1 is less than 0. So we go about by plugging in minus 1 everywhere we see for CB. So we have 5 times minus 1 plus 1 is less than 0. 5 times minus 1 is minus 5, plus 1 is less than 0, and minus 4 less than 0 is a true statement, which means minus 1 is contained in the solution interval for the inequality. All right, let's go ahead, let's see if we can squeeze in a couple more here. Let's go ahead and clear this. Let's say we're given the following. We are given x equals 55 over 4. We're given a weird looking rational number. We want to know that this rational number is contained in the solution set for the following inequality. We have minus 2 over 5 times x plus 5 over 2 is less than or equal to minus 3. So lots of fractions here. Our answer is probably going to be messy, but everything works the same, so let's go ahead and deal with this. So we have minus 2 over 5, substituting in for x is 55 over 4. 55 over 4 plus 5 over 2 is less than or equal to minus 3. Okay, now here a little simplification will do us some justice here. So we have factor out a 2 out of these two terms, factor out a 5 out of these two terms. So we have 11 right here. Sorry, this is getting a little messy. We have 11. So we multiply this out. A negative and a positive gives us a negative. We have 1 times 11 is 11. And the bottom we have 1 times 2 is 2. That's 11 over 2 is much easier to deal with. So we have plus 5 over 2 is less than or equal to minus 3. Let's go ahead and add these rational numbers. Minus 11 over 2 plus 5 over 2 is a minus 6 over 2, which is less than or equal to minus 3. Minus 6 over 2 is the same thing as minus 3. So minus 3 is less than or equal to minus 3. Well, they're equal to, so that checks out, which means 55 over 4 is the funky looking fraction that is contained in our solution interval for the inequality. All right, let's go ahead and do one more. Running out of time here, but I do want to get some more practice in this. Let's say we're told y equals 4. We want to know if this value is included in the solution interval for the following inequality. We have 40 is greater than 5 times 2y minus 4. All right, so here we're actually have our variable on the right side, but everything's going to work out the same. You can flip it if you want to. We'll just leave the variable on the right side just because we're running out of time. So let's go ahead and plug in 4 everywhere we see for y. So we have 40 is greater than 5 times 2 times y, so 2 times 4 minus 4. Go and move over here. We have 40 is greater than 5 times, let's do the math in the parentheses. So we have 2 times 4 is 8. 8 minus 4 is 4. And 40 is greater than 5 times 4 is 20. That's a true statement, which means the value 4 for y is included in our solution interval for this inequality. All right, we're out of time. We'll do some more of these. And in a later video, we'll definitely be checking solutions when we get into solving inequalities and solving compound inequalities. So I'll see you soon.